In today's lesson, we're going to be looking at factor by grouping. So with factor by grouping, the technique that you want to do is you want to group certain collections of terms together in a way that they'll factor. You have a common factor between the two, and then you can kind of factor that out and be on your way to fully factoring your expression. So taking a look here, if I look at these three terms right here, so take a look here, if we examine these three terms right here, you'll notice those three terms can be factored. Now, if you missed my lesson on how we would factor something like this, I'll link that in the top right hand corner. But at any rate here, this term here will factor into 2a minus b quantity squared minus your c squared from before. So I just wrote that back down. Now what we want to do is you want to make the observation that we now have a difference of squares here. If you forget the formula for difference of squares, or you need some work with difference of squares, I'll link that in the top right hand corner. Recall here we have our formula, x squared minus y squared is x minus y times x plus y. This takes the place of our x, and this takes the place of our y. So purple is our x sort of placeholder, and green is our y placeholder. Applying our formula, we get 2a minus b minus c, and then 2a minus b plus c. And take note here, I kind of color-coded it here for your x and your y with purple and green, and then just dropping those colors, you have your final answer here. Now, one question you might be having is, why did I choose to factor these three terms together? Why did I not try to do difference of squares on those two terms instead? The reason for this, let's see what would happen. You'll notice here, if I went ahead and sort of grouped the b squared minus c squared together and then did difference of squares on this, we would not have a common factor in the first two terms. So sometimes you got to try different combinations that would work. I made the observation that if I group these three terms together here, I can then express this as a perfect square, giving us difference of squares, and then we can apply our difference of squares formula. Here we don't have a common factor, so again, an expression is factored if you could express it as a product of other expressions. So I need to have a common factor in both terms to take out so that we have that product that we need. Let's take a look at another example. In the next example here, same sort of strategy. I'm noticing here this is a perfect square, and I can factor a minus sign out of here, and I think I can factor that into a perfect square as well. So let's take a look. And in fact, you'll notice I factor out that minus sign, and we're now left with x squared plus 2xy plus y squared, which is exactly equal to x plus y quantity squared, and likewise our a squared minus 2a plus 1 is equal to a minus 1 quantity squared. Just like before, we now have difference of squares set up for us. Lining this up here, we have our placeholder for x, our placeholder for y. You can see here we have x minus y, x plus y. Now we just distribute and clean this up a bit, and we get, and now our expression is fully factored. Let's take a look at another example. In this next example here, I'm noticing we have a difference of squares we can set up here, and by doing so we get, and notice here we now have a common factor in both terms, and that's the goal for factor by grouping. So we're going to go ahead and factor out that a minus 2b, and doing so we get. Now notice here, whenever you factor something out, you're dividing. So if you take this expression here, and I were to divide it by this expression, we're obviously left with a plus 2b. If I take this expression here, and I divide out that a minus 2b, dividing these two terms out, you'll be left with 1. And a lot of people want to put a 0 there. It's not the case. So now this is fully factored. We should probably get rid of the square brackets and just kind of rewrite this in complete form. Let's take a look at another example. In the following example here, if you take a look here, I can't group these three together. I don't see a combination that will work for these, but I do notice that if I were to group these two terms together, I could factor out an a squared, and I'd be left with an x squared minus 1. Likewise, if I factor a negative 4 out of here, I'll also be left with an x squared minus 1. And there's our common factor in each term that we need to make our factor by grouping technique work. So let's go ahead and do that. We now have a common factor of x squared minus 1 in both terms. We can go ahead and factor that out now, and we now have difference of squares in both of these terms. So you notice we have a difference of squares of x squared minus 1, and then a difference of squares of a squared minus 4. So let's go ahead and apply difference of squares twice, and now our expression is fully factored. Let's take a look at another. This next question is a bit challenging. I encourage you guys to pause the video, see if you can find combinations that'll work where factor by grouping is effective. Okay, so hopefully you tried this question out and tried some combinations that you think might have worked. Admittedly, this question takes a bit of work to find the combination that's going to give you a common factor in each term. Let's take a look at what it is. What I'm first going to do is I'm going to distribute the variable y and z into the binomials. Notice here I do have y squared minus z squared, which I can express as a difference of squares, being y minus z times y plus z. So if I can get a y minus z or y plus z using some combination of 2 of these 4 terms here, we can get a common factor throughout. Our factor by grouping technique will work. Notice if I were to group the following terms, we can achieve that. Notice here, grouping together the terms in green, we have y z squared minus z y squared, which we can factor out a yz and get a y minus z factor. Likewise, grouping the terms in purple, we have here a negative yx squared plus zx squared, in which case we can factor out a negative x squared, also giving us a y minus z. And we know we can get a y minus z in this expression as well. Let's go ahead and do that. Notice here, using our difference of squares formula, we have y minus z times y plus z, so we have that y minus z factor here. Likewise, I factored out a negative yz, and this is written as negative z plus y, but that's the same thing as y minus z. And then I factored out a negative x squared, also giving us a y minus z. So therefore, we have a common factor in each term. Factoring this out of each term, we get, notice grouping these two terms together here, I can factor out an x, leaving me with a y minus x. Likewise, factoring these two terms together, I can factor out a negative z, leaving me with y minus x. So once again, using factor by grouping, we now have a common factor in these 4 terms and can factor further. Notice here, I factored the x out of the first and last term of the above expression, and that left us with a y minus x. Likewise, I'll factor a negative z out of this expression, leaving us with a negative x plus y. And again, to remind you, y minus x and negative x plus y are the same term, so that can be factored out directly, giving us our final result, y minus z times y minus x times x minus z is our fully factored form. So you could try this question again yourself, see if you can identify the combinations that work and test your factor by grouping skills. So you can go ahead and try to redo this question, see if you can identify those combinations yourselves. But this is a great question for just working with your factor by grouping techniques and recognizing some patterns. That concludes today's lesson on factor by grouping. Thank you.